Hi everyone. I wanted to talk through a little bit of the last, say, month or so of changes in the Ethereum space and in the crypto space in general, kind of as a little bit of a 10-year retrospective since we launched the project. I don't know if you know, I was the project manager for the Ethereum launch 2015, release coordinator, did a lot of the early comms work as well. And what I wanted to do was basically try and put the last 10 years into kind of a framework, because I think that it kind of starts with the Genesis block, and then the kind of definitive conclusion of that first decade is the White House's announcements about crypto, whitehouse.gov/crypto, and the corresponding material from the US SEC. So if we take those as kind of two end points, a kind of left and a right bracket for the beginning and the end of the first decade, I want to go back and take a look over that and discuss a little bit about what happened, how we got here, and kind of what's coming next. I'm also going to do something of a cryptography primer, because I think a lot of people who are getting interested in the space now don't really understand what's going on. There's a lot of weird terminology, and I'm going to cover some of that as well. So let me just broadly riff on the history, right? There have been attempts to build consumer usable, consumer friendly cryptographic applications going back, I want to say, to the mid 1990s. PGP was probably the first major attempt. Also, your web browser is a cryptographic application. All this HTTPS stuff that you get in the browser bar, that's all consumer cryptography. When you register a domain name, that's all consumer cryptography. I guess if you buy an HTTPS certificate to go with it. So, the crypto thing is a pretty large scale, widespread part of everyday life. It's just the terminology, you don't typically think of browsing a website as being a use of a cryptographic application. You don't think of a domain name with an HTTPS certificate as being cryptographically defined property. You don't think of the domain name system as being a cryptographic infrastructure. So I'm going to briefly kind of tour over that stuff in a minute and just kind of take you through how that cryptographic infrastructure works, how it relates to things like Bitcoin and Ethereum. I don't really talk about crypto technology very often because there are people in the game that are far, far better at it than I am. But what I am going to talk about and what I am pretty good at is the relationship between cryptographic infrastructure and the shape of cryptographic infrastructure as it relates to questions like national sovereignty, which I think is going to be the next 10 years of adventures in crypto. The first 10 years was basically currency. I think the next 10 years is sovereignty. And that's a very complicated game. Deep stuff in there, believe me. It's one of the most fascinating topics, and I'm going to enjoy taking you through it. So let's talk about the technology for a second. There are basically two branches of crypto algorithms. There's encoding things, encrypting things, making sure that when you've got two people communicating, the communication is secret. Nearly all of the attention in crypto goes into secure communications. Everybody thinks about this right from World War II or even earlier uses of technology for doing encryption back to the beginning of time, strips of paper wound around sticks of a known diameter, this kind of stuff. Going all the way back to the beginning, secret messages, secret messages, secret messages, secret messages. The other branch of crypto is the stuff that Nick Szabo talks about in the Plato protocols, which is the attempt to create seals, right? You have a warehouse, you put a wax seal on the door of the warehouse, and that seal records, or a clay seal, that seal records what's in the warehouse, and you know that that volume will not change unless the seal is broken. In theory, in principle, that's what you want. So those as approaches, this ability to get confidence from examining something about the contents of what's inside of it, obviously that's been a very, very useful thing for trade for a really long time. And these are the kind of two functions that crypto can have. On one hand, you can have secure messaging, on the other hand, you can have authentication of fact. And those two schools of thought come together in a sort of point of somebody sends you a message and there's a digital signature on the message. There was a lot of progress made when we went from that paradigm, because that turned all your messages into evidentiary statements could be used in court. There was a lot of progress when we invented a thing called double ratchet. Double ratchet gets you in a position where you can authenticate who the message comes from, but nobody else can authenticate who the message comes from, that's a nice attribute. So everybody is looking at, Bitcoin, Ethereum, altcoins, L1s, L2s, Avalanche, Algorand. There's all this terminology bandied around. And for the most part, what people don't realize is that all of that technology comes back down to relatively simple operations. Digital signatures, hash rate comparisons, that are a set of kind of atomic Lego bricks from which all these systems are constructed. And none of those atomic sort of Lego bricks are actually rocket science. Digital signatures were a big deal when they were invented. Public key cryptography was a big deal when it was invented. But, 40, 50 years after those things initially came into existence, I think public key cryptography was developed initially in the 70s, trapdoor ciphers. It's so far away since that point of origin that by now we should have gotten pretty used to this stuff, and I think we probably, generally speaking, have. So let me just check my notes here. Right. So of those kind of basic operations, right, we covered encryption, we covered signatures. There are 50 different ways of doing encryption, there are 50 different ways of doing signatures, all that stuff is pretty well understood, right? Nobody else can read the message other than party A, party B, or you can verify as party B that party A genuinely sent the message. Basic operations. Hashes, we come across a lot. You take a very large chunk of data and you produce a kind of 200 character summary of the data. You cannot go from the 200 character summary of the data back to generate the data. It's not compression, but it does give you a unique name for the large data set and you could find it again. Anytime you look at a crypto address, you're kind of looking at a hash, generally speaking. So all of those kinds of structures, these things are little atomic Lego bricks. I will talk about ZK in a second, I'll come back to that. So those atomic Lego bricks are, you could clip them together to get Signal, to get Telegram, to get a web browser, to get message encryption like PGP. You put a bit more work into it, you can get Bitcoin, you can get Ethereum. But there's no real kind of clean, simple limit on the things that you can do with these technologies. It happens that we've got an enormous amount of market success behind a paradigm called blockchain right now. Blockchain is a very, very good idea. What is it? It's a chain of blocks. Each one of those blocks contains some data. The data is hashed. The next block contains the hash of the data from the previous block, plus a bunch more data. That data is transactions. Every transaction has a digital signature on it. Little clippy together Lego bits that generate more and more and more complex structures. We are not at the end of that innovation process. Even with the existing Legos, even without new esoteric like ZK snarks, you could clip together those existing Legos to get a huge range of things that we don't currently do, and they would all work pretty predictably and pretty reliably in the same way that the stuff that we're doing now works. For example, take Google Docs. Google Docs could grow digital signature features so that you could have 50 people collaborating in a document, and every single change to the document had a cryptographic hash validating who made the change. It would then essentially be kind of like a blockchain. Are there applications where that would be really useful? Yeah, maybe. A sort of shared encrypted notepad with that kind of strong authentication of rights could substitute for blockchains in some casual use cases. If you're going to do a meme coin, you could do a meme coin out of a Google Doc. Good idea, bad idea. But, it's those kinds of things which are sort of adjacencies for where we are right now. Then we get to ZK snarks. Now, ZK snarks are actual proper magic. I do not understand the math. I've had very good people explain it to me a number of times. I could vaguely arm wave through it, kinda. I'm not going to do that now because I don't think it'd be useful. But, suffice it to say that it is staggeringly orders of magnitude more complex than the math of the basic encryption systems like digital signatures or encryption or hashing. The snarks are genuinely a next level of mathematical complexity, and the thing that they do is relatively easy to describe. It just doesn't make any sense unless you're pretty deep in as a computer programmer. I will summarize very briefly. You have a function. You can verify that the inputs to the function were valid. You can verify what function it is that did the computation. When you receive the output of the function, you can verify that the output of the function is therefore correct, and the inputs to the function were within the parameters for those inputs. You cannot, however, see what the inputs were from the verified, digitally signed, effectively output. why is that useful? Well, the input could be a bank transaction and a bank balance. The output could be the receipt for the transaction and a new bank balance. I could then give somebody that receipt. They could then use that receipt as evidence that they have had money paid to them, and they could use that to update their bank balance. So that ability to do kind of long transactional verification chains using just snarks, it would be non-trivial to describe how that worked in detail for somebody that was in the field and was expert in it. But there are people doing that stuff. They're building it right now. When you hear somebody say ZK rollup, this is the kind of stuff that's going on under the hood. As I say, I don't know enough about it to take you through the gory detail. Just be aware it's a very different degree of mathematical complexity to the old-fashioned signatures and the rest of that stuff, but it opens up a whole bunch of new terrain. What I want to frame in this is that the social impact of the development of cryptographic algorithms like digital signatures in the 70s, the widespread deployment of those technologies in the 80s and early 90s, these things did not cause immediate social change. Right. A lot of my peers in the 90s thought that encrypted email was going to literally change the world, that you were going to get sort of revolutionary social progress on all fronts because finally people could talk to each other without monitoring. Well, kind of, sort of, that did not happen. And a lot of that is because of the kind of people that were using those technologies, mostly academics. The internet was incredibly deeply rooted in academia in the 1980s, 1990s. And that kind of academic culture of the internet really lasted quite durably until September of 93. That hardcore academic mindset, academic privilege, the kind of better end of internet discourse to this day sounds like people that are arguing in a university. They're smart, they're motivated by evidence, they give citations for arguments, they try not to attack the people, they attack the argument. They're often very learned, they're very scholarly, and around them there are, kind of 100,000 gibbering nitwits who are just basically posting memes of baboons' rectums to each other to try and emphasize how clever they are. That sort of split between these two cultures, between the kind of early academic internet style and the later discourse style, this is what happens when normal people use technology, right? Normal people get hold of kit. They do with it exactly what they were going to do with it anyway, and the kind of bullshit that people would have talked down the pub in, say, 1850 now becomes the kind of bullshit that goes across on social media. The people do not change. While the tools were difficult to use and while the tools were very esoteric, what you got was a kind of privileged academic discourse, and you got a lot of very smart people that would argue with each other about very smart things. Sometimes they might even spontaneously cooperate rather than going immediately to fighting. I know that seems like a radical proposition, but this was a thing that used to happen. Civil, constructive discourse. Rare. So in this kind of framework, what I'm going to frame a little later is that we are in a process where cryptography is genuinely mainstreaming, and the genuinely mainstreaming of cryptography is disruptive socio-culturally and kind of politico-economically, right? The sociology and the political economy are heavily distorted by the arrival of these technologies. And the kind of shenanigans that you see when you get to whitehouse.gov/crypto, the sort of sense of like, does anybody actually understand the implications of cryptography? Is the White House just kind of swinging in the dark? Those kinds of questions and what's behind them, this is the stuff that I'm going to try and unpack. So we talked about the primitives of crypto, encryption, signatures, hashes, ZK snarks. Now I'm going to talk a little about transactions. So a transaction in crypto fundamentally is a statement of intent plus a digital signature. The statement of intent: I have 20 Bitcoin, I want to pay 10 Bitcoin to Bob, I apply a digital signature to an instruction, and that instruction is pushed into the blockchain. At some point it is confirmed, and then there is general assent by everybody that is using that software that I have paid Bob 10 Bitcoin and there's my transaction. So if we were in a position where we had perfect trust and everybody was honest, a transaction would just be an email sent from one person to another saying, I give you 10 Bitcoin. There would be no underlying ledger, there would be no objective record of Bitcoin. It would just be a whole bunch of people subjectively keeping track of how much money they had, and when one person made a payment, they would dutifully deduct their balance, for that payment from their balance. So everything above that layer, if I send you a message saying, I had this many coins, now I have this many coins, everything other than that is sort of tied up in distrust, right? These are technologies that we are using to make sure that people do not break the rules when they send a message to pay somebody. There are systems called mutual credit systems, which have been tried as digital currency systems and indeed paper systems going back into, kind of cultural antiquity. I don't know when the first mutual credit system was, but it was pretty early. And those mutual credit systems, basically any payment instruction is valid because you can have an infinitely large negative balance. So in systems that allow you to go into debt, you can just continue to issue and issue and issue and issue and issue mutual credit systems. Needless to say, those systems tend to go bankrupt. Everybody overissues, and then the thing kind of winds down. If everybody is sovereign and everybody prints their own money, everybody tends to print too much. So if you think of things like Bitcoin as being ways of taking this peer-to-peer transactional framework where I send you money with a digital signature on it, and we then kind of constrain that to stop people spending money they don't have, including double spending. So, I send money to you, I also spend money to somebody else. The tightening up of all the systems that produce these kind of behaviors and these defects, this is kind of the name of the game. Right? This is what we mean when we say crypto. It's the creation of systems that tighten up all those defects. And the ability to get those transactions to just work properly, you send money, a payment is received, everything is exactly as you expect it to be. The ability to build those systems took an enormous amount of engineering, basically because data is not inherently scarce. Right? If I have a file, a picture of a monkey, and I send you the picture of the monkey, I still have a copy, you have a copy, and anybody listening on the conversation has a copy. So if I send you a coin in a dishonest world, and anybody, me, you, or an interloper can take a copy of that coin, and now we all have a coin, you kind of get this notion of massive counterfeiting and inflation and theft and blah, blah, blah. Right? So you want to create artificial digital scarcity leading to Bitcoin. Now, all of those systems, right, Bitcoin, Ethereum, all the rest of that stuff, in principle, those systems can be operated hard or not, right? No link at any level between somebody's passport identity, what you could call their fiat identity, and their cryptographic identity. So you sit at home and you generate a set of keys. You then somehow get some coins, and now you have some coins and some keys, and you can then distribute those coins as you see fit, using your keys to assert ownership of the coins, which you're then sending to people. If we had never seen KYC, AML, CTF, PEP, or OFAC imposed on crypto, if everybody had maintained a kind of religious obligation to hard anonymity, nobody used real names for anything, and there was no exchange point between, say, dollars and Bitcoin. So, Bitcoin was just unpriced, except you could pay for goods and services with it, but you could not exchange it at dollars in some regulated way. If that paradigm had been maintained, crypto would be very much an anarcho-capitalist innovation, right? You would have a parallel society with no names, just keys, and there were sort of early attempts, the kind of Julian Assange libertarian wing of crypto kind of took a crack at that stuff in maybe 2000, 11, 10, 12. And, that sort of an approach, it kind of only worked for that sort of people, and there are really not very many of that kind of people, right? The libertarian gene is not very widely distributed. Most people want a society, and that society has to come with rules, because when you get ordinary people involved, they are not particularly diligent or careful, and so things can go horribly wrong. So the construction of an identity is the construction of the ability to authorize a payment, right? A pays B, is that payment lawful? Well, we need to know who A are and who B is, and then we need to know what jurisdiction the transaction happened in. Figuring out the transaction of jurisdictions has never been a particularly easy process in commercial law, hence a lot of heavy use of things like arbitration. When you get fights about what jurisdiction or transaction happened in, those fights tend to be pretty nasty. So Digital identity is being asserted as a connection to a key, right? Who am I that owns this key? Matters for the jurisdictional reasons, matters because, for example, in a poker game, it's very important to be able to verify that every single player of the game is a separate, distinct human being so that you don't have one person operating three people at the table. This kind of stuff. Digital identity turns out to matter. So once you've got payments and you have identity, you then get the ability to create contract. A pays B for C. C is defined as, I will come to your house, I will pick up a package, I will take it to FedEx, and I will stick a label on it and ship it for you. Okay, great. So the implicit need to be able to specify identity to form contract, you can engineer around that with things like escrow accounts, you can manage some of the exposure by things like arbitration, but basically once you have a hard identity on a digital transaction, what you're doing is ensuring that you have the ability to make an appeal to a nation-state court. And that ability to make an appeal to a nation-state court is kind of best wrapped up in a concept called the Ricardian contract, invented by a colleague of mine called Ian Grigg in 1996. So the Ricardian contract basically bolts together a set of concepts from private commercial law, aka international arbitration, with a set of concepts about digital payment instruments and the ability to store contract text digitally. And that entire bundle, the Ricardian contract, it's one of those things where Ian got it right the first time and nobody's really poked it since. You know, anything that you see where there is a smart contract attached to legal text fundamentally will be a Ricardian contract. You know, terms of service, things like ICOs, any kind of token issuance, there's always going to be a bunch of legal paperwork strung along behind those transactions. In almost all cases, that will be a Ricardian contract. Even if they didn't really mean it to be a Ricardian contract, the norms of the Ricardian contract approach have become so standard in crypto law that almost everybody's using them, whether or not they call them that or not. Right? If you have a contract, if that contract specifies a piece of technology will be used for a payment, if all of that information is somehow stored digitally, and if there's use of an arbitration clause, it's a Ricardian contract. There are usually also parameters in there. Ian's always particular about that, I always forget. So this notion of digital contract then leads to the possibility for creation of digital property. You don't typically think of the Bitcoin documentation and the Bitcoin source code as constituting a contract, but I think that if you were ever going to take a look at that in a really serious way, you would suggest that there is an implicit contract formed by the documentation and the code, and that contract is between the miners and the users. And remember, the users are paying for transactions implicitly by the minting of Bitcoin every time you go around, so you kind of have an expanding currency supply situation. That constitutes effectively a transfer of wealth from the users to the miners via dilution. You could just about frame that as a contract. I would hate to see that litigation ever performed, but structurally this is kind of where we are. So the critical thing about Ricardian contracts is they have the ability to be enforced. Bitcoin has a kind of self-enforcing mechanism via things like being cut out of the consensus. You know, if you come to an aberrant conclusion, you are not in the running to get a block. Proof of stake systems come along, they add staking and slashing to those kind of things, but they're all within this general framework of the attempt is to create what amounts to a self-enforcing contract, aka a smart contract. Is Bitcoin a DAO? Now, this has been a lot of kind of dry stuff, right? What I'm attempting to do here is remove the veil of magic from crypto. You know, it's a set of primitives like digital signatures, hashes, encryption. It's connected together, starting with peer-to-peer. Then you need some way of keeping the peers honest. That turns into solving the double spend problem. That turns into a chain of blocks. Each block is just the previous block plus some new data plus a hash. There are digital signatures on the transactions. You know, is there magic under the hood? There's a lot of very sophisticated engineering, but at no point does it pass into some domain that humans cannot follow. ZK, I think you could argue, does that, but nobody's really using ZK in the base layer. Right, ZK is still kind of new and esoteric. Ricardian contracts, similarly, I take a digital payment for performing goods and services. The goods and services are written down in a digital document that's stored someplace like IPFS. I take money in return for doing the goods and services. I'm now obligated by contract to perform some task. If I choose not to perform the task, then there may be a damages clause, and then there's some kind of arbitration procedure. All of this stuff, right, including commercial arbitration, these are manageable complexity units. Commercial arbitration, there is a paper contract. A and B agree at the beginning when the contract is formed that in the event of a dispute, C, D, and E will be the people that will come and resolve the dispute, and they have the power to extract a payment of up to $50,000 from one party to pay the other. Is there backup for that? Yes, there is. 1958 New York Convention, and that provides for the enforceability of those kind of contracts in 170 jurisdictions, basically every country on earth. So all of those pieces together, right? What we have here is a very broad thing, right? Each individual area is not crazy deep. We've had decades to get used to them. We kind of don't understand how they work. The 1958 New York Convention, that is not recent law. 1970 something for the invention of public key cryptography. That is not recent. We're now generations into this technological transformation. And now it's beginning to get interesting for the people that are running the nation state, and that kind of takes us into the next part of this, which is a discussion about sovereignty and jurisdiction. Sovereignty is a very, very complicated concept, right? We operate inside of a framework bound to a kind of set of historical developments, most famously the Treaty of Westphalia. So the Treaty of Westphalia, a bunch of European nobles come together and they agree that you're going to have kind of strict boundaries for control of land. I dramatically oversimplify. But that is a framework, the Westphalian nation state, kind of gets exported in the age of European empires to everybody, and everybody thinks the natural condition of land is that there is a sovereign entity with an army and a navy that controls that land, and mostly those people speak the same language, culture, and values, except in weird exceptions like, for example, Scotland, where we speak a completely different language and yet are still theoretically part of the same polity. I notoriously grew up in small-town Scotland. So this is a kind of framework, right? Sovereignty, what is sovereignty? Sovereignty is a thing that the state has and you don't. Immediately clashes with these concepts of self-sovereign digital identity. And you've heard people talk about self-sovereign digital identity off and on for years. You ask people what it means, and it's kind of like, well, I generate the digital identity myself, and then I tell you who I am, and you're supposed to believe me. Or maybe I get some third parties in to vouch for me, so my self-sovereign identity is I generate the identity and then other people add attributes to it. That is remarkably different from the nation-state model of sovereignty, which is I have an army, a navy, and a language, and the combination of army, navy, and language turns me into a country. And by the way, I keep stressing navy here because there's a kind of running joke about countries which are landlocked and have no navies apart from like 2 rowboats and a dinghy on a lake. Hence the joke about navies. Really, it's just an army. So in that kind of context, what I want to do is pry apart what makes a state, and then I will pry apart what makes sovereignty, and then we can discuss a little bit about the status of what a blockchain is. Because there are para-sovereign aspects to particularly systems like Ethereum, right? There's my baby. And the para-sovereign aspects of those kinds of systems, you can see people nibbling away at the edges of those things in a number of different ways. And my kind of assertion here is that we have more or less solved the question of tokenizing financial instruments. I think the Americans made it very, very, very clear that this is a go. I think the SEC statement is pretty definitive. I think the technology for tokenizing financial instruments is functionally speaking complete. I don't think there are going to be any surprises there. There are some scaling challenges, but aren't there always? And then the question is, well, what's next? Is crypto just a toolkit for tokenizing financial instruments, or does it do something else? Well, self-sovereign digital, wait, what? And then we kind of get into the next set of questions. So let's talk a wee bit about the nature of the state. I used to work on failed states. I'm a published theorist of failed states. I've spent quite a lot of time talking to people about things like Iraq and Afghanistan, sometimes even getting paid for it. A long time ago. So in this kind of context, I am going to give you my definition of the state, which is that the state is any entity which can retroactively or proactively pardon crime. The state is any entity which can retroactively or proactively pardon crime. Now, that definition flies in the face of commonly accepted definitions like the one from Max Weber, and it's pretty weird looking for people that are not libertarians. Libertarians will immediately be like, oh yeah, of course the state's a criminal enterprise, the prince is but a stationary bandit. And for libertarians, this is kind of can't, right? This is just, if that's what you think the state is, you're libertarian by default, because you want to minimize your exposure to any kind of organized crime, whether or not it has a flag. I have never been a proper libertarian. I've always been far too Scottish for anything other than hardcore anarchy. Libertarians believe that there should be agreed on law and that everybody has to play by the same set of rules. The Scots believe that freedom is the ability to decide what the rules are as you go along. Temporary local agreements versus the idea of immutable libertarian canon. So anarchy is a federated network of patchworks of temporary agreements, continually responsive to local circumstances, kind of how Scotland was governed before the arrival of the British. We very successfully repelled the Romans with their notion of hard fixed law, and that system, which some people have described as the Macocracy, was one of the banes of early America. Scots people kept setting themselves up in Appalachia and just making up the rules as they went along. Scotland. And it's a weird thing to be a Gupta from Scotland. I'm half Scottish, half Indian. Had I known I was going to be raised in Britain, my parents thought they were going back to India, the name they were going to give me was Jack Henderson. So I often think of myself like, maybe I should change my name to Jack Henderson, because that was the name my parents intended me to have if I was going to be raised here. Anyway, this is an aside. Sovereignty, jurisdiction, nothing to do with whether or not I am Vinay Gupta or Jack Henderson. Now, which was, by the way, my grandfather's name. So, in this kind of context, right, state, sovereignty, jurisdiction, retroactive or proactive pardoning of crime. If we pardon theft, we get tax collectors. If we pardon assault, we get police. And if we pardon murder, we get soldiers. So the ability to nominate a person before they have done anything wrong as being immunized from that wrongness generates legitimacy. An action becomes legitimate because you were pardoned in advance for performing the action. If the action was legitimate, whether or not you had received any kind of blessing from the state, it is an ordinary action. I bend over and I pick up a cat. Meow. Boom. I do not need a license from the government to make it not a crime. If I, on the other hand, take that cat away in a plastic box and take it away to the great prison for cats and dogs, whatever they do with strays these days, at that point, I kind of need a state blessing that makes me a stray animal catcher. Right? Animal control. Okay, you're an animal control officer. You could go and take away other people's animals. Okay, there's your responsibility. You have a narrowly defined place where you can break the social norms, and you're legally immunized from doing it. You're also paid to do it. Some people are paid but not immunized. Some people are immunized but not paid. When they are both paid and immunized, these are kind of the officers of the state. Then you have various kind of volunteers and auxiliaries and all the rest of that. There are a lot of kind of thin variations on these things. So when we get to self-sovereign, I am going to note that self-sovereign ID and self-sovereign issuance of things like currencies do not break a law which requires you to bring a note from your mom saying that you're allowed to do it. Right? If we define the state as being the thing that can retroactively or proactively hand out pardons, and we are doing something which is commonly agreed not to require a pardon for its performance, there is no sense in which we require a concept like sovereignty to perform those actions. You say, wait, why does that matter? Right? So to say that one is state-like is to suggest that one has the ability to pardon either yourself or other people from criminal activity. I am sovereign over this land, therefore I can tell people, you are my army, you are my tax collectors, you are my police. I could give each one a set of indemnifications and then they can run off and do their damn jobs. Self-sovereign has never required any notion of the ability to assert independence from consequence. Right? You're not in a position where you're withdrawing consequence by virtue of self-sovereign. So I think that self-sovereign was a kind of conceptual error. It's easy to see how we went up there. If you don't have a very tight definition of the state, when somebody says self-sovereign, it's very easy to think like, oh, kind of like you're in charge of yourself. But if you're a little more ruthless and scrupulous about your definition of the state, I think it's very easy to say that self-sovereign is not the correct terminology. What we really mean when we say self-sovereign is sort of arising from within, endogenous, native. I generate a cryptographic key by rolling a bunch of dice on a piece of paper and noting down the numbers. I then push those numbers into an algorithm that generates a checksum, and from that chunk of code, I now have a key. I'm skipping some steps in there. Now, that as a structure, right? The ability to generate a key and have that be my key. This is mine. My entropy went in there. Nobody else knows what that entropy was. That property is a secret. So if we think of the inside of your head as being a domain in which you have control, it is your head, not anybody else's head. If you have an idea and you don't tell anybody else about it, then that idea only exists in your head. What we have here is individual uniqueness. So my individual uniqueness and the things which only I know constitute a kind of identity. I am an individual unique person. The inside of my head is only visible to me. Okay, great. I don't think anybody's going to object to that. One of the things which is the contents of my head is my cryptographic key. The cryptographic key is then a thing that I can use an algorithm to demonstrate ownership of without giving away the ownership. A digital signature. You show me a document, I agree with the document, I take the document into my private protected mind space, I process it, I put a digital signature on it using some more math, and then I hand you back the document. Right? And that ability to prove that I know a secret without giving away the secret, that was the great discovery of public key cryptography. Again, there's a lot of confusion about public key. One key cryptography and two key cryptography probably would have been a nicer way of framing it than symmetric and asymmetric. Nonetheless, you have the terminology you have. So, two key cryptography, I publish a key and say, I know the secret that drives that key. You send me over a document, I sign the document using the secret that drives the key, and then I hand you back the signature. In that process, am I sovereign over anything? No. We're just using the fact that I have a mind and that I have a private container for the things in my mind. It could be a notebook, there's your notebook. It could be, could be anything. Could be a computer if you've got a way of keeping it secret. By the way, for those who have that particular sense of humor, this is a blank notebook. So, there is no anti-memetics division. So that framework, right, where you have a conceptual model in which there is a private section of your mind and you have the ability to prove some of the contents of the private section of your mind, passwords, shibboleths, the ability to demonstrate that you know a shared secret. Were you there when Bob did the thing? Oh yeah, when Bob did the thing where he broke it in half. Wow. Well, you were there, right? Or you heard about it from somebody that was there. The old school tie, the notion of a shared context, like human beings have been identifying people in group and out group based on shared secrets since probably the invention of anything, right? I mean, that could very, very easily be older than human language. So if we think of cryptography as being about the sharing of secrets and the self-sovereign concept is simply the ability to prove to somebody that you know a secret, and there is only one person in the world that knows that secret, therefore that person is you, all of that stuff neatly sidesteps these questions of sovereignty. Sovereignty is very appealing as a concept until you really peel apart what it means, but I think it's very hard to argue that sovereignty means something when we're defending the assertion that an individual is sovereign because they have a piece of information that nobody else has. I just don't think that's how sovereignty works. Now, where does that take us, right? When we start really looking at the way that crypto works, you want to say self-sovereign because if it's your keys, it's your crypto and nobody can take it away from you. Therefore, you have sovereignty over that crypto by virtue of having the keys. Not bad, right? I have sovereignty over a gold bar because I buried that gold bar out in the wilderness and the only person that knows where the gold bar is me. Close parallel. I don't think you'd want to use sovereignty for that. Also, can crypto operate without the nation state? Oh, in principle, sure. in practice, if every Bitcoin mine was a solar-powered fortress with machine guns constantly beating off barbarian hordes, I'm not sure that any Bitcoin would ever actually get mined. I think that Bitcoin is kind of riding along in the envelope created by the nation state in terms of stability. I don't think Bitcoin can create that stability, and let's hope that doesn't become an important assertion. So if you're already dependent on the nation state for incorporation, for basic security, and for complex supply chains being managed by international cooperation and all the rest of that stuff, sovereign, not sovereign, one would tend not to say that Bitcoin creates a sovereign environment, but we may come back to that. And then there is this kind of notion of, well, what about free speech, right? Free speech and First Amendment carve-outs for crypto, I think, are fundamentally important. PGP was defended very notoriously by a free speech argument back in the 1990s crypto war. They published the source code in books and then exported the books as a way of avoiding regulation on export of cryptographic technology from America. I mean, as stupid pet tricks go, it was a pretty impressive one. I'm sort of surprised they got away with it, but there you are. So, this notion of sovereignty over keys. I have a key, therefore I have sovereignty over this Bitcoin. I have a key, therefore I have sovereignty over this Ethereum smart contract. We collectively vote on the functions of a DAO contract, and therefore that gives the group sovereignty over those assets within a set of rules that are defined inside of the contract code. All of that stuff is kind of kicking around in a terminologically inexact way, right? It's all inherently kind of fuzzy, kind of difficult. It's not very clear how the pieces fit together exactly. And a lot of that terminological confusion really bites us in the ass when the normies arrive. And the normies are here in bulk, right? A lot of very, very ordinary people are starting to use crypto for a lot of very, very ordinary day-to-day transactions. Everybody thinks, okay, well, here we go, they've finally arrived. Now, that is a model, that is a framework, that is a system or a pattern of activity. If you don't tell ordinary people what's going on, they will tend to listen to whoever last to talk to them. Hey, we got this amazing thing called crypto. What is it? Well, you buy this picture of a fridge, and in 15 years, your children will be able to go out to college based on your ability to pay for that college, based on the value of this picture of a fridge. Right? Now, Bitcoiners were highly skeptical that NFTs had value, and the kind of response to that was, well, if NFTs don't have value, why does Bitcoin have value? Well, Bitcoin has value because of scarcity of supply. Yeah, but anybody can copy the Bitcoin source code, and they can make another Bitcoin that's identical to the first Bitcoin, apart from the fact that less people use it and it costs less to buy. Surely, no, that's communism. Shut up now, you're not allowed to talk about that. Okay. So do we have a closed, finite money supply because of crypto, or do we have an infinitely elastic money supply that anybody can extend if they have the ability to persuade other people that the assets they've created just have value? One would tend towards the second assertion, right? Unless you're going to see use of law by nation states to say that only Bitcoin is legal tender within their borders and other cryptocurrencies are not legal for payments, unless you see that kind of fusion of crypto authority and coin authority, unless you see something like that, there's going to be trouble. So those kinds of models, right? What is sovereign, what isn't sovereign, how these pieces fit together, all of that stuff really starts to matter once regular people get involved, right? Once the so-called normies arrive, once you're in a position where you've got very, very ordinary people coming to the table and wondering how things work, the explanations that people are given and the way that things are explained become critical to their ability to function in that environment. Which brings us around to this question of, is Bitcoin money? Is it a commodity? Is it a social agreement? Is it a point scheme like you would get from an airline? Is it some kind of weird futures contract based on future transactional capacity being sold by a collective of miners? Is it some kind of sui generis thing which kind of emerged from the sky and should be regarded as, perhaps a religious artifact? What is that? And the obvious answer is Bitcoin is just Bitcoin, and you then have to tell people that it is Bitcoin and they need to learn how it works in order to understand it well enough to use it. However, the regular population doesn't understand gold refining, they don't understand how Sabre is involved in the plane ticket business, they don't really understand the functions of the nation state in any significant way. They're told there are a set of rules for interacting with the nation state: turn up once every 4 years and vote, right? Do what you're told by officers of the law. And that's really kind of about it. That's just about as far as it goes in terms of how people understand the state. They know what their options are, they know what choices they're presented with, but they don't really understand the mechanism behind that generates the choices. I can send my Bitcoin to A, B, C, D, E, and an infinity of other people, or I can keep it myself, or I can, in theory, put it on an exchange and somebody can hold it for me. And that's basically my choices, right? That's kind of sort of the things you can do with Bitcoin. But you don't have to understand how Bitcoin works in order to be able to do any of those things. The problem that we have here is lawmakers. So lawmakers are in a position where they're looking at Bitcoin and they're looking at crypto and they're trying to figure out what the rules are of the game without really understanding the technology. And here I'm going to say something pretty brutal, which is this. A reasonably smart person who has had a profession like law or medicine sat down in front of a smart person with a whiteboard with a few days, right, 2 or 3 days of effort, can understand Bitcoin about as well as you're going to understand it without reading source code, right? When you get to Ethereum, the complexity bar is considerably higher because of Turing completeness and virtual machines and all the rest of that stuff, compilers. It's a fair bit harder. However, you could probably go from an understanding of Bitcoin to an understanding of Ethereum that's good enough with another few hours of work, another half a day. But then you hit ZK snarks, and you might be able to explain the impact of ZK snark to a reasonably smart person, but I'm a reasonably decent computer scientist, and I've got some background in mathematics, although not much of one. And I don't think that a team of smart people could teach me what a ZK snark is to the point where I confidently understood it in less than, say, 3 or 4 weeks of dedicated daily effort. And it would be a struggle, and I am good at this, reasonably. So if you were to take, a lawyer in their 60s without any particular experience with computer science, and you tried to explain to them what a ZK snark was to the point where they were competent to regulate it, I think you would be there for centuries. And that is a real problem, right? I mean, the question is whether you can encapsulate the complexity in a meaningful way. This is a microprocessor, you don't have to understand how it works, you just need to understand that software could be regulated or left free. Here are your options. So you could make an argument by analogy that software is software and you don't really need to understand it, how it works in order to regulate. But actually, practically speaking, I think a lot of the reason that the internet got relatively free reign is that nobody understood it well enough to really want to interfere with it. It was not destroying society as it stood, and maybe we should just kind of let that thing run. And I think that part of the reason the internet did get kind of a free ride is because nobody understood what it was well enough to stand on it. So then we kind of come along into this situation of so what do we do with crypto? SEC has decided to go all out. White House has decided to go all out. We're going to make America the global center of crypto technology. We fought against that technology tooth and nail by hook and by crook, administration after administration since the 1990s. Obama made perilous threats in 2016? Went to South by Southwest and read the Riot Act, we're really against this stuff and you need to sort it out. All of that stuff, suddenly the government does a 180, there's a complete change, they're going to write this stuff into regulation, they're probably going to write it into law, there's a huge transformation ongoing, and probably very few of the people involved in that fundamentally understand what they're doing or its implications. There will be massive pressure on the UK to change track and keep up with that. MiCA in the EU basically is the most conservative possible crypto regulation. If you do the same amount of work that you would have to do an IPO, you could potentially tokenize a bicycle. They might get pushed into making some updates, and a lot of countries that haven't really made a decision about what they're going are likely to follow the American example. So my concern is that what we're going to get is a lot of very, very low quality legislation, and particularly low quality regulation from financial regulators of crypto, because there is no fundamental understanding of what is happening. So what I want to suggest for anybody watching this is that we make a concerted, disciplined effort to sort out the terminology before we wind up with 8 billion users, right? Website is a pretty solid piece of terminology. You know what it means. Domain name, pretty solid. App, pretty solid. Cryptocurrency, pretty fuzzy. NFT, really pretty fuzzy. And that's not just because these things are kind of new. Websites are not that much newer than NFTs. By the late 90s, everybody knew what a website was. It's because there is a very deep and mysterious property of financial instruments. Financial instruments are kind of shared hallucinations. A website is like a book name or a book number. The ISBN number for this text is 123456789101112. The website is 162.121, 42.7. Boom, there's your website. Oh, it has a name now. Yeah, the name refers to the number. Oh, just like the book title. Yeah, just like the book title. Okay. So that notion of a number that brings you pages, we'd kind of had some time to get used to, arguably centuries. Financial instruments that exist only as software or executable code which generates financial instruments in a domain that nobody has control of because of the blockchain consensus mechanisms. There are like 4 or 5 things which are being reimagined there simultaneously. The blockchain creates an environment that is essentially global rule of law as long as the law can be represented as code. If I can represent the code, if I can represent the law as code, if I can represent the contract as code and I can upload it to a server, I have the ability to essentially write global law. Bitcoin, is that global law? Well, it can't compel anybody to do anything, but it does obey its own set of rules. Okay. Ethereum, is that global law? Well, if you have to stake value in a smart contract, and if you don't behave yourself, that value is transferred to somebody else's damages, that has many attributes in common with law. That's essentially like a fine. But you can only represent some classes of behaviors in those systems. So what we have is these kind of very, very fragmentary attempts to make tiny little domains which are sort of self-regulating para-jurisdictions? What is that exactly? Is that, is individual Bitcoiners are not self-sovereign, but Bitcoin itself is self-sovereign, shared state, all this kind of stuff? So this question of cleaning up the terminology and how do we straighten this out so that we get a decent global consensus on all of this, I think that is going to take some time to sort out, right? But I don't think that we should just sit on our hands and wait for that to happen, right? All over the world, everybody outside of America is about to get pulled into a completely new game by the American government's decision that crypto is go. And the American approach on this is to try and centralize crypto in America. We are going to bring all this stuff onto American infrastructure. We're going to do all this stuff here. Now, you look at the United Nations, you look at the League of Nations, you look at the WTO, the WIPO, you look at, any of these international institutions, World Health Organization. You look at any of these international institutions, and what you have is a consensus of nation states about the future of the world. And the nation states represent their populations, but they vote one flag per vote, not, for example, weighted by population, right? China does not get 74 votes relative to, say, Sweden. So I think it'd be more like, Sweden is very small, 5 million people-ish, China 1.4 billion, it's quite a ratio. So these kinds of frameworks where we say kind of sort of sovereign, how do these pieces fit together, is Bitcoin actually an environment, is it kind of like a country? I would suggest these things are like international treaty organizations which are convened by individuals rather than being convened by nation states. Now, that's a mouthful, right? So Bitcoin, and I keep saying Bitcoin, I really mean Ethereum. I'm just using Bitcoin because it doesn't have the complexity of smart contracts, and smart contracts magnify the complexity of everything that I'm discussing here by a factor of Turing complete, right? The argument, the rationale, the political stuff works just as well for Bitcoin as Ethereum, but if we put Ethereum into this conversation, the complexity ginormously increases. So I say Bitcoin, I mean Ethereum, I'm just leaving out the complexities caused by Turing completeness. The important thing for this discussion is the consensus mechanisms. So if we have the consensus mechanisms, these things are a bit like international treaties. Many people who are individuals from all around the world join together in a unified agreement that they will run a particular piece of software in a particular way, and that will produce a service, let's call it a service for now, called Bitcoin. And that notion that what you have is individuals convening an international association, that is akin to the UN, it's akin to the League of Nations, it's akin to the World Health Organization. If you had built this thing in the 1960s and you'd built it top down with, IBM mainframes and fleets of consultants, rather than one or more anonymous wizards, you might have said, well, so we're going to have the World Bitcoin Association, and the World Bitcoin Association will have a set of member banks. Those member banks will get together to build a global clearing rail, and that clearing rail will issue financial instruments in a whole new way. And, oh wait, that was done. It was called Visa, right? So Visa was an international protocol operated by a set of member banks, and it created a new set of financial instruments, and those financial instruments are carried every day by billions of people. They're called credit cards. Visa was the prototype for Bitcoin, right? It was the ability for a set of non-state actors, these were not banks, these were not countries, these were companies. A set of companies came together, they agreed a protocol, the protocol allowed them to move money around the world in a new way, and then they did, and it was extremely successful. So if we think of Visa as kind of setting the direction for Bitcoin, and by implication Ethereum when it grows up, Ethereum is still my baby, then you would be kind of in a position where we could start talking to the nation states about what Bitcoin is. Bitcoin, it's kind of like Visa, but rather than being convened by member banks, it's convened by individuals. Some of those individuals represent companies that do Bitcoin mining, but you can do Bitcoin mining as a single individual with a single machine at home. Just about. Well, Visa works. It isn't exactly a currency. Bitcoin has a currency, right? Well, yes, but other than that, is Visa with a currency sovereign? Definitely not. It has no ability to indemnify for criminal behavior. Okay, so there is no sense in which these systems are competing with the nation state because they do not compete with sovereignty. No, it's just a payment instrument. Well, it's a payment rail plus it as a token. So it's kind of like Visa if Visa printed their own air miles. Yes, Visa with air miles. Okay, we're not mentioning Ethereum yet. We're not going to deal with the smart contracts. That kind of terminology framework, if everybody had been clear about that when Bitcoin was invented, and that was how the Bitcoin white paper had sold the idea, probably Bitcoin would have failed, right? It needed extravagant terminology, and it needed a crazy, crazy, wild approach to, wow, everything is so amazing. It needed all of that stuff in order to be able to get over the hump, right? The 1990s told a lot of crazy stories about how great the internet was going to be. Practically speaking, most of that vision is not yet fulfilled. Similarly with Bitcoin, there was a whole bunch of crazy storytelling at the beginning. This is how great it is. This is how everything is going to work. Oh my God, it's going to be so amazing. Well, okay, yeah, kind of, sort of, maybe. But now that we're at the implementation stage where the nation states are finally throwing down and driving this stuff, what it is and how it works is very important because we have to slot into the existing international system. Right. Bitcoin has to take a place at the global table. That place cannot be as some weird piece of technology that's being bossed around by the American government. That is the death of Bitcoin completely. We have to be thinking about this as being something like an international treaty organization, where you have the ability to think about Bitcoin as being an association of people from all over the world collaborating to operate an economic protocol. The closest thing we have is Visa. Kind of like Visa, but no company involved. Well, some of the entities at the day were companies, some are individuals. And, that is a kind of hump that you could get a lawmaker over, just about with some effort. If we don't strip away some of the magic and get the people making law clear about what these systems are and how they work, what is going to happen is misregulation, right? The state is going to misunderstand what these things are. The state is then going to categorize them in pathological ways. Once they've been categorized in pathological ways, they're going to get pushed around by the courts to try and make them do things that they don't do, can't do, or they're going to try and make them stop doing things that they can easily do. And that would be bad, right? What we need is clarity about something like Bitcoin is an international association. It's kind of like a non-governmental association or an intergovernmental association. However, it also has similarities with Visa. It's not associated with member banks. It is possible for individuals to participate in the consensus mechanism, also true of Ethereum, especially true of Ethereum. And, as a result, it gets a seat at the international table beside things like the World Trade Organization. Who represents it? One coin, one vote, and you just hold an election and anybody that chooses to vote with their coins can? Maybe? That would be a fair way of doing it. There probably isn't another fair way of doing it. Do you have multiple chains? Well, of course, you've got Ethereum and you've got any number of other chains, so maybe you need to figure out some kind of representative framework for those. One coin, one vote, highest dollar value wins. Sounds dreadful, but what else can you do with the technology as it stands? We're not going to go around and scan the eyeballs of every single person involved. Figuring out how we take our seat at the global table, among the myriad international bodies which are necessary to constitute the world as it stands, nobody's really put thought into that. There's been a lot of thought about how we slot crypto into the nation state level. I would suggest that the American regulations this year are going to settle that more or less once and for all. That is the relationship between crypto and the nation state. It will be the American model and MiCA and a few other variations, but I think that phase is done. If we're in a position where we slot crypto in under the nation state, then for the rest of time, crypto will be at the whims of whoever happened to get elected in that jurisdiction that year, and life will eventually suck because most of those people will not understand what it is or how it works. If, on the other hand, we could get it slotted in beside, let's say, the Red Cross, Bitcoin, yeah, it's kind of like the Red Cross. Oh, yeah, there are branches all over the world, and they all cooperate to operate a set of really critical international services. A payment rail, that's a critical international service. Well, we're using it for A, B, C, D, E, F, G. Do you want those things to stop? No. Can you replace them with banking? No, we can't generate identities. Well, self-sovereign. Okay, maybe not self-sovereign, but they generate their own keys and then we can send the money directly to them, and all they need is a phone and they don't need a bank account, and they don't even need an ID. It's really useful for refugees. You could kind of make an argument that in some scenarios the presence or absence of cryptocurrency could be the difference in life or death between people in war zones, in refugee situations, in famines. There are lots of places where the ability to send money directly to the front line, even if all the identity infrastructure has collapsed, turns out to be incredibly useful. You could send food, or you could just send Bitcoin. So framing an argument, and here I suggest that this might be worth somebody with some policy mojo really investing in, Coinbase or Crypto.com or Blockchain.com or some consortium of the big guys, just sit down and start writing some checks to the policy folks. That as a mechanism where the objective is to figure out how to get Bitcoin, etc., to the table as a peer organization to things like the Red Cross. I think that is going to be the challenge of the next 10 years. We need to escape the confinement of the nation state as an institution. We need to get this internet sales stuff regulated like other internet sales scale stuff. Take a look at the Red Cross. That's a really interesting example. Take a look at the UN. What does it really take to constitute a UN? Take a look at the Catholic Church. How exactly is that represented internationally? I'm not suggesting that Bitcoin is a religion, but you could suggest that Satoshi was actually a time-traveling agent of the Buddha, something like that. So that's what I want to basically frame, right? I think we've sorted out our business with the nation state. I think the next step is sorting out our relationships with global governance. I suspect that's going to be the dominant theme of the next 10 years, and I, for one, am ready for this adventure. Thank you very much for listening.